Hello and welcome to the Wednesday, January 28th, 2026 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Jacksonville, Florida. And this episode is brought to you by the SANS.edu Master's Degree Program in Information Security Engineering. Well, today's diary comes from one of our undergraduate interns, Faris Azhari, wrote about the initial stages of romance scams. You probably received some of these text messages yourself that look like they were just misrouted, someone typing the wrong phone number and looking for an old friend. Well, this is just the start of it. The goal here is to retain the interest of the victim, that's the recipient of this text message, get them involved in a more elaborate conversation, and of course, in the end, getting money out of them. Now, what Faris found here is that there were likely multiple scammers involved here impersonating the same individual. Also, the money in the end, was apparently being extracted via crypto coin scams. Faris, of course, didn't follow up on the actual crypto coin scam, but let it be at that stage. The scammer was, of course, quite insistent after investing some time into the conversation to actually get Faris then to take the next step, which didn't happen here. Couple sort of comments on this. So first of all, these scams are very common. Most people don't fall for them, but sadly, ever so often, someone does fall for these scams. And from what I have heard from people who try to help victims is that it can sometimes be very difficult to convince the victim that this is actually a scam. So that's sort of an added problem here. And I think it's probably also related with the victim not really wanting to admit that they fell for something that in hindsight was a very obvious scam. The other thing that sort of made the news ever so often is that the scammers here, which, are essentially sort of call centers, aren't always scamming voluntarily, but that they're also victims of some sorts of human trafficking and such that are basically being forced to conduct these scams. So a very complex case and scam overall. And best thing, of course, is don't respond to these scams. Maybe have some fun with them if you want to do it and waste some time of yourself and the scammer. But your time is probably more valuable than the time of the scammer. And then we do have a patch for the patch that was originally triggered by React to Shell. Remember, back in December, we were all worried about React to Shell, the remote code execution vulnerability in React server components. Well, that was patched relatively quickly, but then there was a denial of service vulnerability that wasn't completely patched. So that was patched also, I think, around New Year. And now we have another denial of service vulnerability that had to be patched. So that's another sort of leftover of that React to Shell. Again, it's only denial of service. So it's not another React to Shell, but something that you probably want to, patch as you get around it. And OpenSSL released updates, this time fixing one vulnerability in more recent OpenSSL version, that's 3 and later, that may lead to code execution. Now, I say here may, and should probably say it's probably not going to lead to code execution. It's probably more going to be a denial of service. But what's happening here is that we do have a classic stack-based buffer overflow. This one is in the CMS auth enveloped data parsing, and this is something that happens before sort of any signatures and so are verified. So it's pre-authentication and could potentially be exploited via SMIME messages. The actual vulnerability, so if you're classic buffer overflow, you have these IV parameters, for example, that should have a fixed length. So that's the length of the buffer being assigned. But then due to the fairly tricky, sometimes ASN.1 encoding in these certificates, the key material, you can actually specify a larger length than the standard allows, which then leads to that buffer overflow. So get it updated, but I don't think too many systems are using OpenSSL version 3 yet. It's still sort of a little bit newer, so if you don't use that, you don't have a problem here. And like I said, the exploitation is tricky because usually these stack-based buffer overflows are reasonably well mitigated with various compiler options and such. And then we got an interesting Kubernetes issue, I call it. I don't call it a vulnerability because Kubernetes calls this expected behavior. What's happening here is if you're connecting to the API and you have get permissions to connect to the API and you set up a WebSocket, the problem is that your permissions are only verified as you're starting the WebSocket, because with WebSockets, it's not like normal HTTP. You no longer have individual requests, you now have a connection. So it's with normal HTTP, you have to authenticate and access control every single request. With WebSocket, you really, if you do it right, only have to basically authenticate and access control the user at the beginning of the connection. However, the problem here is that then later the user may send create or permissions requiring create permissions, like for example to the /exec endpoint, which does give the user access to execute arbitrary commands on the kubelet. So that's the basic risk here, that if you are giving a user limited permission to the node's proxy, then they can escalate their permission. Really sort of more an awareness item that you're aware of this, that you know that what you're doing here by giving these permissions. As the advisory here notes, well, it's sadly sometimes needed for monitoring and such, that you do assign those permissions. So it may not be that easy to further and accurately restrict those permissions. Well, and this is it for today. So thanks for listening. Thanks for liking. Thanks for subscribing to this podcast, and talk to you again tomorrow. Bye.